stated before, linear velocity is distance per unit of time. So it's linear speed. How quickly did you move from one point to the next in a straight line? And so here's just a lot more verbiage about that. And this says, if a point is in motion on a circle, its linear speed is calculated by one of these two formulas. That's what the double equal sign means. V is the variable for linear velocity. So V equals arc length over time, or radius times angle measure over time. Either one. So this is actually two equations. Either one will give you the linear speed. So I'm going to underline linear speed in V so you know that that's what they mean by V equals. And then these other variables you should know from what we just talked about. So let's go ahead and look at an example. It says, see page 449 and find the linear speed of the tips of the blades in example 8. So I need to grab my book. Sorry, I'm getting all up in the camera here. Hopefully my face is still in the camera now. Okay, so 449. So this is the problem they're talking about. It says a wind machine used to generate electricity has blades that are 10 feet in length. The propeller is rotating at 4 revolutions per second. Find the linear speed in feet per second of the tips of the blades. So we've got a lot of information given to us here. I'm going to do a big no-no and I'm going to highlight in the book. Ooh. All right, so we've got 10 feet in length for the propellers, which you can see in the diagram. And then it says it's rotating at 4 revolutions per second. Find the linear speed in feet per second of the tips of the blade. Okay, so I'm going to start with, what are we looking for? They're telling us to find the linear speed in feet per second. So I'm going to write that down. We're looking for V in feet per second. And it tells us that the blade is 10 feet long. Well, think about those blades. Those blades are turning in a circle. So really, the length of a blade is the radius. So that's 10 feet. Okay, so since they gave us radius, I have a hunch that this is the equation we're going to use. V equals r theta over t. Now, did they give us a theta? Looking back at my problem, it said the propeller was rotating at 4 revolutions per second. So that actually does give us an angle measure, 4 revolutions. So over here I'm going to put theta equals 4 revs. Now here's the thing, that is not in radians. So do not just go and plug in 10 and 4, because that's wrong. We've got to convert this to radians. So theta equals 4 revolutions. Now let's think about how many revolutions, or how many radians are in 1 revolution, I should say. That one might be a little bit tricky for you guys right now, but think about 1 revolution is 360 degrees. How many radians is that? If you need to, you can look at your cheat sheet. In your cheat sheet, and pause it, you can go look at it, should say 2 pi. 2 pi is the same as 1 revolution. And so we can skip the degrees and just go straight to converting to radians. And so theta is 8 pi radians. And remember, I don't have to write it. It's the invisible unit. And so to calculate my velocity, by the way, that was revolutions per second. So this is radians per second. Now I can calculate that velocity using this formula because I have the radius and I have theta in radians. So velocity equals 10 feet times 8 pi radians per second. which equals 80 pi feet per second. And if you don't like that weird number, you can approximate it to be 251.32 feet per second. Ta-da! And there we have the linear speed. So if you were to take the circle that this blade is spinning in and stretch it out into a flat line, then that's how much flat distance it's covering. Even though it's moving in a circle, if you like undid the circle, unwound it, and straightened it out, it's moving 251 feet per second. That's pretty crazy if you think about it. But that's how much linear distance it's covering. So now, in our last tab, we're going to talk about angular velocity, how many radians something is covering or how many revolutions it's covering.